Hi friends, welcome to my channel. You are watching PHYSIO-FACTS. I am bringing the interesting facts in the field of physiotherapy and myself Dr. Alphonse Swami. Before getting into today's video, please do subscribe my channel as well as click the bell icon so that you'll get the notifications as soon as I make new videos. In this video, I am going to tell about the direction of mobilization. To understand that, we need to know about the direction of motion as well as the axis of rotation. Direction of motion can be understood by knowing the concave-convex rule. For that, we need to understand about osteokinematics and orthokinematics. Osteokinematics is the angular movement of the bones. The movements what you see from outside, like abduction or flexion. Orthokinematics is the movement of the articular surfaces, which we cannot see from outside. Those are the movements that is happening within the joint between the articular surfaces. The movements can be glide, roll, or spin. The glide can also be called as slide. According to concave-convex rule, when a concave articular surface is moving over a convex articular surface, the sliding is in the same direction of the angular movement of the bone. For example, when a concave articular surface, like the tibia, moves over a fixed femur, which is convex articular surface, the movement of the intra-articular structure as well as the angular movement of the tibia will be in the same direction. On the contrary, when a convex surface is moving over a fixed concave surface, the sliding will be in the opposite direction of the angular movement of the bone. Why is the difference? What really happens when convex surface is moving over concave and when concave surface is moving over a convex surface? Why there is a difference between the angular movement and the intra-articular movement? The reason is one single point. Yeah, it is the axis of rotation. The axis of rotation determines what sort of movement is happening. The convex articular surface possesses the axis of rotation, so the angular movement and slide will be in opposite directions. But the concave articular surface does not possess the axis of rotation, so the angular movement and slide are in the same direction. To understand this in a better way, I have a demonstration which is going to be very simple to understand. This is the axis of rotation. An axis of rotation is a point through which movement is happening. It is an imaginary line. For example, let us discuss about the shoulder joint. Here, when movement is happening between these two articular surfaces, it is always the convex articular surface that possesses the axis of rotation and not the concave surface. This is a key factor that determines how the articular as well as angular movements are happening. Let us discuss this further so that we can understand more deeply about the concepts. This is a clock. We see that every day, but what happens you see when the second's arm moves around a fixed axis? The tip of the arm is denoting one direction of movement, but the base of the arm moves in a different direction. The point here is the part of the arm, second's arm, that is on either side of the axis of rotation moves in different directions. For example, now the tip of the needle is moving upward but the base is moving downward. When the tip of the second's arm is moving towards the right now, but the base is moving towards the left. So The points or segments on either side of axis of rotation moves in different direction. So as I said before, the convex articular surface is possessing the axis of rotation. So naturally, the angular moment, the sliding are in opposite directions, because the points lying on either side of the axis of rotation will follow different path of movement. Now the angular motion is moving towards the left, but the sliding is moving towards the right. Discuss with a structure or a bone that have a concave articular surface with the same demonstration here. Since the concave articular surface does not possess the axis of rotation within itself, so the angular moment and sliding are in the same direction. So let us discuss very closely with our reality. This is the shoulder joint, and the shoulder joint with axis of rotation, when a convex surface moves over a concave surface, what happens? The angular motion is in the upward direction, the intra-articular movement is in the downward direction. As we discussed before, the part of a bone lying on either side of the axis of rotation follows different path. This is in case when convex surface is moving over a concave surface. Let us discuss the same with the rotation movement. When convex surface moves over a concave surface, we are seeing the superior view of a shoulder joint, and I am going to demonstrate what happens when external rotation is happening. The angular movement is denoting external rotation, the intra-articular movement is showing anterior glide. So to improve external rotation, the therapists have to prefer anterior glide, because the segments of a bone lying on either side of the axis of rotation follows opposite directions when convex surface is moving over concave. Here the movement is, the angular movement is external rotation, the intra-articular movement is anterior glide. Let us think about what happens when a concave surface moves over a convex surface. Because it doesn't possess the axis of rotation, the sliding and angular moment are in the same direction. Hence, when a concave surface moves over a convex surface, the therapist will decide the direction of mobilization along the direction of the angular moment. Let us discuss one more example of rotational movement when concave moves over a fixed convex surface. This is an example of a distal radio-ulnar joint. The concave articular surface of a radius moves over convex distal ulna. So when the person does pronation, the angular motion of pronation as well as the intra-articular movement follows the same direction, because concave is moving over convex. So this gives an idea for a therapist. When concave moves over convex, he will be giving the glide along the direction of the movement, angular movement. Why we are talking about the slide? Because it is the sliding component of the joint motion that is used to restore the joint play and reverse hypomobility. It is not rolling movement, because that produces only compressive force between the joint. But sliding movement or gliding movement is the one that releases the tension in the capsule, that improves the mobility within the joint, thereby the hypomobility can be improved. Therefore, it is the direction of sliding that determines the direction of mobilization force. So, being a physical therapist, we have to improve the range of motion, means it is the sliding that helps. So it is must to know about in which direction sliding is happening, so that we can choose what will be the direction of my mobilization. So one final word is, when convex surface is moving, the angular moment and the intra-articular moment are opposite each other because it possesses the axis of rotation. On contrary, the concave surface doesn't possess the axis of rotation, so the angular moment and the gliding will be in the same direction. Okay friends, so far we were discussing about the direction of mobilization by understanding the axis of rotation. So I hope this video would have helped you to improve your knowledge, and if you like this video, please share and subscribe my channel. And this is Dr. Alfonso Guruswamy signing off. Thank you.